Neural networks are the starting point of machine learning, which is inspired by the neuron in biology. Neurons form a huge web in our brain that helps learn things. People stimulated the neural web in our brain on our computer model, which makes our model capable of learning things just like us. Now let's look at how an individual neuron works in our machine learning model. First of all, it receives signals from other neurons. And for each signal received from different neurons, they have different weight. If you want to express the sum of the signals mathematically, it will be W1x1 plus W2x2 and plus W3x3, in which W represents the weight for each signals received. If the sum of the signals minus the threshold that the neuron has is greater than 0, it will output signals to other neurons. Otherwise, it will not. We use a Heaviside step function to express the logic, in which 0 means there's no output and 1 means there is an output signal. Because computer isn't human brain that could only output 0 and 1, the function isn't limited to the Heaviside step function, but an activation function. Sigmoid function is one of the most common activation function used in neural networks. In the real world, people replace the minus theta in the function to plus b in order to avoid mistakes. A web like this is formed with all different neurons. The blue circle represents the input, which is the data given to the model in order to train them. The green circles represent the output. The output of the computer model is the predicted value, and the correct value is always known during the training process, represented in T1 and T2 in this situation. We want to find the regression line for the predicted value and the correct value, where the square arrow is the smallest in order to optimize the neural network model. Here is the equation representing the square arrow for 1 point. The 1/2 is meaningless in this situation. We add it into the equation to make the computer easier to compute. If we add up all the square arrows, it will be the square arrow for the entire model, and we need to minimize that value in order to optimize our model. And the way we minimize it is that we need to take the derivative of the function as we have learned in calculus. However, there are two variables in the function, which is p and q. So we need to use partial derivatives. Once we have that, the function representing the regression line would be easy to calculate. And after that, we have completed an easy model for neural networks.